An engineer is inspecting a construction site. While on inspection, a cement block accidentally falls from rest from a 53.0 meter high building. When the block is 14.0 meters above the ground, the engineer, who is 2 meters tall, looks up and notices that the block is directly above him. How much time at most does the engineer have to get out of the way? So for the given of this problem, let us have this illustration. So let this be our given as shown. So the building is 53 meters high, and then when the cement block is 14 meters above the ground, the engineer started to notice that the block is falling directly above his head, and the engineer is 2 meters tall. So at this point, when the cement block is falling, so let's say it started from point A. If the building is 53 meters high, from point A to this point, let's say point B, to the cement block, the block already travels a distance of this point, it already travels a distance of 39 meters. But we need to treat this as a vector, because since the block is traveling downward, we need to denote this with a negative sign. So this will be negative 39 meters, the displacement of the cement block. And from this point, point B, to this point, let's say point C, point just above the head of the engineer, at this point, the block will still have to travel a distance of negative 12 meters. Again, we need to put negative to denote the direction of the cement block. So here's the cement block, it's falling, so we need to denote the displacement with a negative sign. So this is now our given. Now once the man sees the block, the engineer must get out of the way in time. So the velocity of the block at the instant that the man looks up, we need to determine the velocity first at this point, at point B. Velocity at point A is 0, because assuming that it started from rest. If we can get the velocity at B, if we can get the velocity at point B, then we can compute for the time that it will took for the cement block to travel from point B to point C. If we can get the time from point B to point C, this is the time that the engineer must run away from this block so that it wouldn't hit his head. So this is the time that we are looking for. So the engineer must get out of the way during this time. So this is what is asked, this is what is required in our problem. The time that the engineer, at most, the engineer must have to get out of the way so that he will not be hit by the block. So the required is the, let's say, TBC, or the time it will took for the engineer to move away. And that is the distance from point B to point C, because the engineer only notices the black at point B. So from point B to point C, the black will still have to travel a distance of 12 meters. So we need to get first this velocity, the velocity at B, for us to determine the time that it will took for the cement block to travel, to still travel a distance of 12 meters. This velocity B will serve as our initial velocity from point B to point C. Now let us first solve for velocity B, or the velocity at point B. To get velocity B, we can use equation number 4 in our 4 basic kinematic equation. According to our 4 basic kinematic equation, if we will consider from point A to point B, VA being the initial velocity and VB the final velocity, we can have an equation for VB. VB squared is equal to VA squared plus 2GY. So we use G since it is free falling. This G is acceleration due to gravity, and we use Y to denote that it is traveling vertically on a vertical distance, a vertical motion. Now we need to compute for velocity B. Now velocity B will be equal to the square root of VA squared plus 2GY. But velocity A is assumed to be 0, because according to our problem, the cement block accidentally falls from rest. So the initial velocity is assumed to be, must be 0. So this will become 0. What will remain is just this term 2GY, but this Y is the displacement from point A to point B. In our illustration, the displacement from point A to point B is negative 39 meters. Now going back to our equation, we can just compute velocity B by substituting to this equation 2 times negative 9.8 meter per second squared. Velocity is negative, going downwards, times negative 39 meters. So by solving this, we can get the velocity at point B to be negative 27.65 meters per 27.65 meters per second. Velocity B should be negative. We should put negative here. This negative sign denotes that the velocity is going downwards. So it is very important for us to denote our variables like velocity and displacement using a sign convention. If it is going right, positive; going left, negative; going upward, positive; and going downward, negative. So since the block is falling, then the velocity at point B is negative. So we will use this later on in our solution for time. Now we need to get the time. Going back to our figure, we need to get TBC, because this time will be the maximum time needed for the engineer to move away, because the block will still have to travel from point B to C, which is equal to negative 12 meters. Okay, so let us now compute for this time BC. To compute for time BC, the time it will took for the engineer to move away from his place, we can use equation number 3. Using our equation number 3, kinematic equation number 3, vertical motion, we can have the equation y is equal to v initial t. But to get time BC, our initial point by now is VB. So this is now the initial velocity times time, because we are getting time BC. So the final will be at point C. The initial will be at point B. So this will now become your V initial. So VBT plus 1/2 GT squared. So this came from our equation of y is equal to V initial t plus 1/2 GT squared. Again, G is acceleration due to gravity, and this T is your time BC. This is your time BC, which is also our time, the required time for the engineer to move away. Okay, now you will notice if we will try to put all the values. Okay, this y is also the displacement from B to C. So if we will let us go back to our illustration. This y, B to C, is equal to negative 12 meters. Okay, and our velocity at B is negative 27.65 meters per second. Now let us put that into this equation. Now YBC is negative 12 meters is equal to V initial, VB is negative 27.65 meters per second times TBC plus 1/2 of gravity, 1/2 times the gravity, which is negative 9.8 meter per second squared TBC squared. So that is now our equation. So simplifying now this equation, we'll have negative 12 meters. Now let us first put away the units so that it will be much more clearer, because the units will just be cancelled out if we will now be having the time, the value for the time, so it's irrelevant. Let's say this is negative 12 is equal to negative 27.65 T BC. This will become minus 4.9 T BC squared. Now if you will notice this equation is a quadratic equation. This is in the form, if we will transpose these terms to the left side of the equation, this will become 4.9 TBC squared plus 27.65 TBC minus 12 equal 0. So if you'll notice, this is in the form a x squared plus bx plus c equal 0. So this is a quadratic equation. So we can solve this by using a quadratic equation, which is a longer solution, or we can just simply input it in our calculator. If you have a mode for equation mode, if your calculator is 991 ES, then just have to press mode 5 3. So mode, then 5, then 3. Then you just have to input these numerical coefficients to A, B, and C. So if you'll solve this using your calculator, you will have two roots, because a quadratic equation has two roots. So you'll have two answers. If you'll try to enter this to a calculator for equation mode, we'll have 4.9, then 27.65, and for C is negative 12. Now we'll get to value for time. The time will be, this will be the two values, the two roots. First is 0.40 seconds, and the other one will be negative 6.04 seconds. Now, which one is correct? Of course, the correct one will be this answer, because there is no such thing as a negative time. So this is what we call a null solution. So the answer should be 0.40 seconds. So the engineer must move away quickly. So if he sees the block 12 meters above his head, going back to our illustration, the engineer sees it 12 meters above his head because he is 2 meters tall. Now the engineer must move quickly, 0.40 seconds, so that he will be safe from harm of getting hit by the cement block. So this is quite a long a solution, a quite challenging one, but as you continue to study more and practice more problems, encountering this kind of problems, it will be much more easier for you to understand and analyze problems such as this. So our answer for this problem is 0.40 seconds.